In this video, I'm going to explain the solutions for the 2019 Freshman Number Bases contest. In this first problem, we have the value 53 in base B, and that is the representation of 33. We're supposed to find the value of B. Well, we know that when in any base that we might be working with, we are going to know that the first place is the 1s, the second place is the B, the third place is the B squared, and so on. So since I have 53 in base B, I can represent that as 5B plus 3. And I know that that equals 33. So at this point, both of these numbers are in base 10, which gives me an equation that I can solve. And solving for this equation gives me that B equals 6. In question 2, we are given two values in base 2, and we want to know how many positive integers are between those two values in base 10. So again, I started out here by thinking of how would these numbers look if they were expressed in base 10. And I started by saying, well, how much is each place value worth? And then once I thought through that, I went ahead and translated the number. So this first number is equal to 19, and the second number is equal to 26. Now, typically when you're trying to find a range of values, you're going to do your max minus your min. And if it happens to be inclusive, you have to add 1 for that endpoint. And so we do 26 minus 19 and then add 1 because we are inclusive, giving us 8 values. For this third problem, we are in base B, and we are representing, we are saying that a to the 6th equals 1,000 in base B. And we want to know what a base A representation would be of B squared. All right, so the first thing I said was, well, I have to be able to get myself a conversion factor, so to speak, between A and B. So if I know in base B I have 1,000, then that means that my B to the third place right here is the only position that I have. So B to the third, let's say that again. So 1000 is equal to B cubed if I were to turn this into base 10. And I know that that is a representation of a to the 6th. So I can say that B cubed equals a to the 6th. And if I were to go ahead and cube root each of these, then that would give me the relationship that B is equal to a squared. So now that I know that, I want to find out, okay, well, what is my base A representation of B squared? So I can take this equation, and similarly to how I solved it before, I can now square both sides, getting me that B squared equals a to the 4th. And then last but not least, if I am in base A, I know that each of these place values, this is the 1, a squared, a cubed, a to the 4th, and if I'm looking for a to the 4th, then that's when I have a 1 here and 0 elsewhere. All right, number 4. Here we are supposed to take this value here, 3743.5, from base 8 and turn it into base 10. And we want to express it as a decimal. So just like how we would typically go ahead and do this, the 1's place, the 8 squared, and the 8 cubed for our expansion, in order to get the decimal point, I have to do 1 over 8. And so now once we've figured out this, now it's just a matter of doing the arithmetic. 8 cubed is 512, multiplying that times 3, we've got 7 times 64, and then just figuring out, we know that 1/8, figuring out 5/8, we know that 5/8 is 6.25 or 0.625. If you didn't know that, you could always do long division to extrapolate that decimal. And then we add them all together to get 2019.625. All right, now this last value, we really have to think about the different ranges of what we are working with. So I'm told that X and Y are integers with 2020 digits in each of their base 10 expressions. The base 100 expression of X plus Y has D digits, and we're supposed to find all of the possible values of D. All right, so let's first start by thinking about the range of values that X and Y can be within. So first of all, if we have 2020 digits in base 10, well, what we want to think about is given any base, like let's say I had these two digits here and I was in base 10, then the largest base 10 value with two digits is going to be 10 squared minus 1. So the smallest, I'm not explaining this very well. If I have 2020 digits, let's think of it this way. If I have 2020 digits, then the greatest value it could be is 10 to the 2020 and then minus 1. So that is why I am saying here that x is less than 10 to the power 2020. However, in order for it to have 2020 digits, it has to be at least 10 to the 2019. Because again, that would give me a 1 in this greatest digit and then zeros elsewhere. So we're essentially saying that my number is between 1, 0, 0, 0, 0, 0, all the way to 1, 1, 1, 1, 1, 1, 1. Okay, so that's what this range is giving me that I have here highlighted in blue. So that's going to be true for both x and y, because I know that x and y are integers with that number of digits. So if I'm trying to find a way to represent the sum x plus y, well then let's go ahead and let's add those two together. So that's what I'm doing right here. And when I add these two minimums and I add these two maximums, then that's going to give me 2 times each of those. Okay. So at this point now we're saying, all right, well, if I were to go ahead and express this and figure out what I have, what we could think about is that any number in base 10 to the k power, so 10 to the k power, has at most, or has k plus 1 digits. And we know that because, like we just looked at here, if I'm looking at these values, this is the 1, this is the 10 to the 1, this is 10 squared. So in this case, if k is equal to 2, then I have 3 digits. So I know that any value that has a power of 10 to the k has k plus 1 digits. And when I look at this, I know that x plus y is in between 2020 and 2021 digits. So if I was going to go from base 10 to base 100, just like we saw in those example problems we were doing where we had a base 9 and then we went to base 3 and we saw that we could double the number of digits. Well, if I'm going from base 10 into base 100, I am going to essentially take every 2 digits and replace them with 1 digit, because I know that the tens place, 10 times 10 equals 100, so 2 tens digits equals 1 100ths digit. And so I can go through here and I can group these. And so that's what we're going to do. We're going to group every 2 values. And so what that means is that we divide the number of digits for both scenarios. So if I had 2020 numbers or digits and divided it by 2, I would get 1010. Or if I had that extra digit, because again, remember, we're taking 2 digits and consolidating it with 1. So the other option that I could have is I could have 2021 digits, and when I divide that by 2, I get 1011. So those are my 2 possible values for D, 1010, 1011. All right, that is all.